talk about the electronic lab notebook Sciformation ELN, and also a bit about the research data platform Sciflection that we have created recently. We are in the middle of a revolution since about 20 years, the digital revolution, which is changing many aspects of our daily lives. So for a chemist working in the lab, the question is, how does this revolution change the way we do research? And one aspect is that we may not go to the library that often anymore, but instead look at PDFs or search databases. And talking about the actual research, this is still pretty much analog. So you still have glassware and heat guns, and of course there's also a lot of digital research, but I think the majority is still physically in the glassware. And of course people use machines like the GC you see here to generate a lot of data, and it's becoming an important task to organize this data. So on the left side, you see actually how I organized my research when I was still in inorganic chemistry. And surprisingly, people do cutting edge research and still work with paper notebooks and have printouts that are organized in folders. And but I think that this can be done better. And but it's kind of challenging because the devices in the lab are often old, and then the way experiments are done is very diverse. People are used to a certain way of working, and sometimes if a PhD or if a postdoc is in the lab for half a year, it doesn't make sense to build up a lot of knowledge in software, in a specific software, and then jump to the next lab and work with a different kind of software. It's also a matter of money. I'll talk about that also. And the availability of tools, at least back 20 years ago. And our ideas were that it's also important to have convenience, that you get support by the software and not just document the data in a database for the future, but that you get an immediate benefit. And also that a high level of integration is useful to make the work more convenient. When I joined the group of Professor Goossen, he was already quite revolutionary with a digital lab notebook that he had developed more or less himself, based on a chemical database software. And the problem with this chemical database software was it was running only on Windows XP. And at that time, Windows XP was already dying. And that's why I had the task to develop a new software to replace it, and also to overcome some of the intrinsic limitations of that software. So that was my PhD project in 2006 until 2010. At the Technical University of Kaiserslautern. And Open Inventory and also its successor, Sciformation ELN, they both integrate many aspects of the lab work. So not only the experiment, but they organize the analytical data, they organize projects, and one of the most important aspects, I would say, is that they organize the chemicals, the starting materials you are using. Because when working with this old software, we had a separate tool for this purpose. And I found it quite annoying to always switch the programs when I was planning my reactions. So instead, I had the idea to integrate this into the lab notebook. And it seems people like this a lot. Yeah, so, well, as you can see here, yeah, I'll jump to this. This is more a take-home message, probably. And here you can see that our software covers the whole workflow, starting from literature and any previous experiments, starting material, getting to the experiment, analytical data, and finally publication or patenting, so that everything is covered on one platform. I already mentioned that it's tricky to cover the diversity of science because the experiments are very much different between people working in the lab. And for this purpose, we have integrated a template tool. Here we see first template, which is just text and tables, which is most generic, but of course also doesn't give many benefits. Here we see the chemical reaction tool where you draw a reaction equation. This is pretty similar to Chemotion, I think. And unlike in Chemotion, here you also get the data from the integrated chemical inventory and the safety information, which I think adds value and is quite convenient for the people using it. But of course, people don't do just synthesis and catalysis. They have special kinds of experiments like flow chemistry, or they're using autoclaves. They do electrochemistry, ball milling, use microwaves, photochemistry, whatever. And for all these fields, we have created templates so that specific parameters like the wavelength or the pressure or whatever people want to later on search for can be entered into separate fields, which is quite useful to later on use the data. If this is just in the text, it's much more difficult. This is a template we call workflows, where you can combine multiple steps and either enter free text or specific parameters like stirring rate, temperature. In the next slide, we see a chromatography template where you can enter the fractions of a chromatography and the parameters, how it was done. And this structured data storage, I think it increases the quality of the data that is collected compared to free text. We also try to extend to the field of biology, where people are using well plates, or where they are working with proteins and they don't want the Lewis structures, but such 3D imagery instead. Or some people work in the field of genetic engineering and they find it useful to have a viewer for plasmide maps. I don't know much about this field myself, but our clients tell us what they need, and we try to offer these additional features, these extensions in a collaborative way. Yeah, this slide is to discuss how a multidisciplinary lab notebook can be implemented. And there are multiple approaches. I will not go into the details, but in principle, I would say we follow this third approach, and we try to have one piece of software which covers many aspects that are needed for all kinds of lab notebooks. This is the one, this is the blue parts. And then we have these red parts, which are modular and which are flexible, open towards new kinds of experiments, new kinds of spectroscopy, to cover these specific requirements. And I think we're quite successful in this field. Yeah, let's again look at the scientific workflow. We had a quick look at how we can document experiments, and now we come to attachments. This can be literature, which we can extract using the DOIs. But the most important thing, I think, is the analytical data that we can transfer from the devices or the file servers that are being used to collect the data. We also have an automatic transfer function that is based on the name of the lab notebook entry and the file names to make it more convenient for people. I think Chemotion has a similar function. We have an extensible set of Python programs built in that processes the raw data. So we cannot just deal with JChem, but we can deal with a huge number of file formats. And we try to generate a preview image and to make a peak list that people can later on search for, or to compare graphs that were measured within the software directly without using external software. People were asking for tools to annotate anything on these preview images, or here you can see how TLCs can be annotated. This is a bit like in ChemDraw, I think. And we have a viewer component for 3D structures, for X-ray or computational data that may be useful for inorganic chemists or for quantum chemistry. And in some cases, of course, we need locally installed software like Mestranova. We cannot replace NMR software. This would be overambitious, I think. So Marco has developed a tool recently which performs this integration and allows to upload the interpreted data back into the database so that it's everything at one place. Searching the data, of course, is a very important part, because that's why people use electronic lab notebooks. So it's like having one's own private SciFinder and drawing a reaction equation, adding some parameters, and then getting the search results for these queries. You can also search for anything that is in the attached literature, and then when you get the search results, you see if any project or experiment or spectra, in this case there are none, but if they are linked, you can click on these buttons and then navigate through the database to find the information you are looking for. We can search for similar spectra, so you can upload a mass spectrum, for instance, and then we can try to build a list of similar mass spectra that have been recorded previously, which may be useful to identify impurities or to elucidate an unknown structure. I think this is a lot more than a normal database can do. Well, so as a quick summary, I would say that this integrated system saves time, helps to reduce costs. Accessing the safety information can contribute to working in a safer way in the lab, and collecting this data in a structured way also helps to open new possibilities that have not been there when using paper. And well, I would say the software is quite popular meanwhile. So this is some of the clients that we have. And well, I would be happy if more clients join this community and well, make use of these benefits. We already mentioned at the beginning that we have created a research data platform. It's called Sciflection, kind of like reflecting the science. And well, all these research data platforms are probably intended to complement with publications. So in publications, you mostly see the successful experiments, and you can only make searching. You can only search in the literature using tools like SciFinder or Biochemistry or Reaxys. I think it's like with the iceberg, 90% is underneath the waterline and is not visible. And we try to make this accessible in a convenient way so that you can search also the experiments that have not been that successful, and that we can make this data accessible also for machine learning purposes. And yeah, I think this will generate a lot of value in the future. And we can also import data from other tools like Open Inventory. We can import experiments from Chemotion and other lab notebooks so that we gather as much useful information as possible. And well, see by yourself, you can search for experiments and then get results as if it would be a lab notebook. You can try it yourself at sciflection.com. You don't have to sign up. It's totally free. And then you can look at the results and copy the ID of the result. This is not on the slide, and paste it into your own lab notebook to import the experiment so that you can then, yeah, in German, people would say nachkochen. So you can replicate the experiment or make a modified version and work based on this data. We also have a substance database where you can search for information for NMR spectra. And Marco is working heavily on this to make it more useful for people and to extract data from what we get as upload. Well, this was really a lot of content in a very short time. And if you would like to have a look at the slides, just scan the QR code, and thank you very much.